So today we are talking about solving quadratics by square roots. The last time I saw you, we were solving quadratics by factoring, and we had our factoring review, and then we used those to solve quadratics. Today we're using square roots. We're taking the square roots to solving quadratics by square roots. And I will give you a quick refresher of square roots. If you remember correctly, square roots are anything that's written in this form, right? And ultimately, the question that we're asking when we ask for the solution to a square root is what number times itself equals that, right? And if we look at the square root of 4, we're saying, well, what number times itself equals 4? And you guys would say to me, the answer is what? This is an easy one. Thank you, Race. I appreciate that. Race says that 2 times 2 equals 4, and he is absolutely right. So that we can say that the square root of 4 is 2. But what we always forget is that -2 times -2 can also equal 4. So as we move up now into the maths, we think of it instead of just the square root of 4 equals 2, we think of it as it equals +2 or -2. And that's what this plus or minus means. It just means it can equal +2 or it can equal -2. So if I had the square root of 9, we would say that that equals plus or minus 3. And it always helps to kind of know your squares, like that 1 squared equals 1, and 2 squared equals 4, and 3 squared equals 9, and 4 squared equals 16. And it helps, like, if you're doing these, to have this stuff available. Like, bring it up online. Look at these things, right? 36, 7 squared equals 49. And I can go on forever and ever with those. But it really helps to know those things. But sometimes you're not going to get a perfect square underneath there, right? Like if I have, let's say, the square root of 24, I have to look at the pieces of that. And I have to go, okay, well, I can go 24 is 4 times 6. I can look at it that way. And I go, well, 4 is a perfect square. So I could pull 2 out with that. But 6 just breaks down to 2 times 3. So I can't do anything with that. And that would have to go back under. Now, if you can't look at it that way, you can break it down into factors. You can go, well, I've got 24. And 24 is 2 times 12, which is 2 times 6, which is 2 times 3. And I can look at this and go, well, I got a pair of 2s, so I can pull a 2 out, right? But these 2 and 3 don't have a match, so they have to get multiplied and put back in. So here I could pull out a 2, and I'd have to put that 2 times 3 back under. So I'm trying to think of another one for you that's that's good. I didn't write down a bunch of these samples because I wanted you to. If I have the square root of 21 and I look at that, I go 21 is just 1 times 21, which is 3 times 7. Nothing else works. I can't pull anything out of there. There's no perfect squares in there. So it really does just equal plus or minus the square root of 21. You can't break it down. If you look at, say, the square root of 15, right? If I look at that, I go, okay, well, 15 is just 3 times 5. I can't break those down anymore. Neither of them have a pair. So the square root of 15 is just the square root of plus or minus 15. But But if I have, say, the square root of 63, let's look at the square root of 63. 63 is not a perfect square. But if I look at 63, I go, well, 2 doesn't go into it, but 3 goes into it 21 times, which is 3 times 7. And I have a pair of 3s here, so I could pull a 3 out. So I get equals plus or minus 3 times the square root of 7, because the 7 doesn't have a match. Does that make a little sense to you? I know you guys have done this before, but it's been a while since you've done square roots. So I want to make sure you understand how to break them down, because you can't just stick them in a calculator and give me a decimal answer. So you're getting it, Daryl? All right. Explain it again. So if I have a perfect square, if I have the square root of 49, you can understand that that's plus or minus 7, right? Because 7 times 7 equals 49. But if you don't have a perfect square, say I have the square root of 54, I need to look at 54. It's not a perfect square, so I have to look at what's in there. I go, okay, well, it's an even number, so I know I could divide 2 into it, and that would be 2 goes into it 27 times, which is 3 times 9, which is 3 times 3. So I got a pair of 3s I can pull out. Then I have these 2 that don't have a match. So I could rewrite this as plus or minus. For the pair of 3s, I can pull out a 3. And then I have to multiply these 2 back together and put it underneath. So it's just breaking down square roots. It's just remembering how to break down square roots. I will put a link in for a video too, I think, on how to break down square roots into Power School if you want to review that a little better while you're working on it. The reason we're doing it, though, is because we want to be able to solve quadratics using square roots, right? We want to be able to find solutions. So solving quadratics using square roots. Forgot how to spell square roots. So there's some steps that we can follow. One thing to remember is that the only time you can do it is when you have them of the ax squared plus c equals 0 form. And what I mean by that is that there's no just x value, right? We have been dealing with stuff that's ax squared plus bx plus c. In these forms, when we're using them, when we're using square roots to solve, we can't have that bx term, right? We can only have the x squared as our variable. And I'll show you that in terms of real numbers too, but I just want that to be clear. If there is a bx term, if there is just an x term, then you can't do it. You have to have an x squared and then a constant, something without a variable, or not. Steps. Number 1, isolate x squared. That means get it by itself on one side of the equal sign. All you want on one side of the equal sign is x squared. 2, take the square root of both sides. 3, simplify. Simplify the radical. That means the square root. Right, the square root. and place plus or minus in front, right? Because that plus or minus shows that we're getting two answers. We're getting a positive of it and we're getting a negative. So let's look at this in real world problem solving, because steps are great once you see them being used. So let's start with our first example. We will say we have x squared minus 64 equals 0. Well, our first step, it says, is to isolate x squared, which means we want to get x squared to be the only thing on this side of the equal sign. So we're just going to move this 64 over by adding 64 to both sides, right? Because 64 minus 64 is just 0. So here we're just left with x squared equals 64. Now it says take the square root of both sides, right? We're going to take the square root here and the square root here. The square root of x squared, well, that's x times x. So it just equals x. That's why we do it. The square root of 64, well, that's kind of an easy one because 8 times 8 equals 64. So we just have 8. So we've simplified the radical, but it says we also have to place a plus or minus in front. And the reason is that 8 times 8 equals 64, but so does negative 8 times negative 8. Right? So that was a nice, simple question to get started with, right? A simple problem to start out with. So we're going to make it a little harder and then a lot harder, because that's how we do things in math. We lull you into a false sense of security. Like, here's this easy way to do something, and now we're going to make the problems really difficult. So if I have 7x squared plus 8 equals 15, first thing we need to do, we need to get that x squared all by itself. So we just need to undo everything that's being done to it. And we're going to start with this 8 that's being added to it, because it's like backwards PEMDAS. You do it in the opposite order. So we're going to do negative 8, so that we're left with 7x squared equals, conveniently, 7. Then we still have this 7 being multiplied to x squared, so we're going to go ahead and divide both sides by 7. And we'll be left with x squared equals, well, 7 over 7 just equals 1, right? Next, it tells us we'll take the square root of both sides. So I'm going to take the square root of this, and I'm going to take the square root of this. And that's what we're looking for, right? Because the square root of x squared is just x. It's why we isolate that x squared in the first place. So we're left with x equals, well, what number times itself equals 1? It's an easy one I'm throwing at you right there. Thank you, Ryan. Appreciate that. Right? So we've simplified this now. We know that x equals 1. We just have to place the plus and minus in front of it, because 1 times 1 equals 1, but negative 1 times negative 1 also equals 1. And we need to indicate that there's two answers. And in quadratics, it's really important to indicate that there are two different solutions. So that plus or minus really means something to us here. So will it always be pretty? No, of course not. Right? Let's look at 81x squared plus 5 equals 21. We'll do this one. This one's getting a little harder, but not totally to the really hard stuff yet, but we will get there. So we're going to start undoing everything that's being done to this x squared. And I'm going to start by subtracting 5 from both sides, where I get 81 x squared equals 21 minus 5 is 16. And then we've got this 81 being multiplied to it. So I'm just going to divide both sides by 81. so that I have x squared equals 16 over 81. And we're going to take the square root of both sides. And when we do that, I'll show you how to break that down. X equals, well, this is ultimately saying the square root of 16 over the square root of 81. And you can always break down square roots like that when they're in a fraction form. So the square root of 16 is just 4, right? 4 times 4 equals 16. The square root of 81 is 9. So we have plus or minus 4/9. Not so bad, right? Let's look at one that gets worse, because these have all been perfect squares at the end. We need to get some, let's say, not so perfect squares at the end. Let's try 2x squared minus 9 equals 55. So we're going to start by getting that x squared all by itself again. We're going to start undoing everything that's being done to it. We have 9 being subtracted from it. So we're going to add 9 because it's the opposite. And we've got 2x squared equals 64. Right? Now we have this 2 being multiplied. So we're going to go ahead and divide out that 2 so that we have that x squared all by itself. So x squared equals 32. And so when I go to take the square root of both sides here, our 32 is not a perfect square. So we need to look at that. We need to look at what makes 32. Now, I can in my head go, okay, well, that's 16 times 2, and 16 is a perfect square. But if you can't do that, it's okay, right? You can go, well, I know 2 goes into it because it's an even number. So that's 2 times 16. And then if you see that 6, then you see the 16 and you go, oh, well, that's 4 times 4. You can treat it that way and go, okay, well, I can pull a 4 out, right? If you can't, though, you can go, okay, well, that's 2 times 8. And then that's 2 times 4. And then that's 2 times 2. And you can go, okay, well, I can pull 1 2 out. And then I can pull another 2 out. And then I'm still left with a 2. So you can look at it any way you want in that respect, right? You could do it as 2 times 16. Well, that's 4 times 4. And if you know that, you could just pull a 4 out. But otherwise, you could break it down and go, well, I got a 2 I could pull out here and a 2 I could pull out here, which is 4. And then I have 1 2 left. So I have to put that back underneath. And I get plus or minus 4 radical 2. Either way, your solution is the same. My handwriting got kind of sloppy on that one, though. Did that make a little bit of sense to you? You guys feel like you can work with that a little? I'll do another couple of problems just so that you can have multiple examples. Because that way when you go back, if you're messing up while you're doing the homework, you have more video examples you can go through. Let's look at 9x squared plus 3 equals 111, right? Isolate the x. We're going to subtract 3 from both sides, so we're left with 9x squared equals 108. And then we're going to divide both sides by 9 because we're still trying to get that x squared by itself. And we get x squared equals, I believe that's 12. It is 12. Right? And so now we're there. We've got that x squared equals. We just have to take the square root of both sides. And I go, okay, well, this equals x. But 12 isn't a perfect square, so I have to look at what 12 is. Now, I know it's 3 times 4. So let's look at that. Well, 4 is just 2 times 2, so we know we can pull out a 2. So we've got plus or minus 2. But that 3 doesn't have a match, so it's got to go back under. Trying to see if I've got some that are like way harder. But it doesn't look like I have anything that's all that much more difficult. I do have one with a fraction, and I did assign you one with a fraction, so I will do one last example, and it will have a fraction in it so that you can see how to handle it. And it's similar to the one that's in your homework problem. And then that should be enough. That's a lot of examples, I feel like. So we've got negative 1/2 x squared plus 1 equals negative 39. Right? So the first thing we're going to do is we're going to subtract 1 from both sides, and we get negative 1/2 x squared equals negative 40. Does anybody know how to handle that negative 1/2 that's being multiplied to the x squared? Mashka, how about you? Do you know what to do with that 1/2, that negative 1/2, how we're going to get it off the x squared? You're not wrong. Do you know what you would multiply by? Pretty much. You're very close. You're very close. It would be negative 2, right? Or negative 2 over 1. So really good. So what Mashka is basically saying is that if I have a fraction, right, and I want to clear that fraction away, all I have to do is multiply by its reciprocal, right? Which means you would flip that fraction over. So 2 is 2 over 1. In this case, we have negatives, so we want to multiply by a negative. Because what it ultimately gives us in the end is 2 over 2, which is 1, and that's how we clear it out. But I can't just multiply one side by this negative 2 or 2 over 1. I mean, the reason she said 2 is because we don't ever write that 2 over 1 in our minds, right? It's just a whole number. But we know that it's there, right? We're going to multiply that by negative 2 over 1, and we're also going to multiply this times negative 2 over 1, right? Because we can't do something to one side and not do it to the other. And the reason we do that is it leaves us with that x squared, because this is just 1 now. The good thing about a fraction like this is we're left with here just negative 40 times negative 2, which is positive 80, right? That's all we had to do to clear that fraction, and now we can just take care of taking the square root of both sides. So bam, bam, and we're left with x equals, and when I look at the square root of 80, I go, okay, well, that is, let's start with 8 times 10, right? This is 2 times 4. This is 2 times 5. This is 2 times 2. So for every couple of 2's, I got a pair of 2's here and a pair of 2's here, right? So I can pull 4 out. But I still have that 5 that doesn't have a match. So it's got to go back under. So get comfortable with your square roots is what I'm saying. I think you've got ample examples here to get you through. I tried to do something that was like each of the homework problems so that you could go back and refer to this video if you need to while you're doing your homework. I did post a worksheet, and hold on, let me stop the video. They don't need to hear about your homework.